a shadow over the Atlantic. Picture, if you will, the grey waters of the North Atlantic in the autumn of 1940, waves rolling endlessly toward horizons shrouded in uncertainty. Beneath those deceptively calm surfaces lies a crisis that would reshape the very foundations of industrial warfare. The Battle of the Atlantic has begun in earnest, and with each passing day, the mathematics of survival grow more stark, more unforgiving. In the war rooms of Whitehall and the Pentagon, staff officers move colored pins across vast maritime charts with increasing urgency. Each pin represents a merchant vessel. Each vessel represents thousands of tons of desperately needed cargo, and far too many of those pins are being removed from the board entirely. The German U-boat campaign is achieving a terrifying efficiency that threatens to strangle the Allied war effort before it can truly begin. Consider the numbers that kept military planners awake through those dark nights of 1940 and early 1941. Britain, that island fortress, required 43 million tons of imports annually just to survive. Food, fuel, raw materials, ammunition, everything flowed across those treacherous sea lanes. Yet by the spring of 1941, German submarines were sinking merchant ships faster than all the world's shipyards combined could replace them. The arithmetic was brutally simple. At current rates of loss, the Allies would run out of cargo capacity long before they could mount any meaningful offensive. The crisis reached beyond mere tonnage statistics. Each sunken freighter represented not just steel and cargo, but irreplaceable maritime expertise. Experienced crews who knew how to navigate convoy formations, how to read the subtle signs of submarine activity, how to coax maximum speed from aging engines when survival depended on it. These men were disappearing beneath the waves at an alarming rate, taking with them decades of accumulated knowledge about the sea's moods and mysteries. In Washington, a particular urgency gripped the Maritime Commission. Admiral Emery Land, a man whose weathered features bore the marks of a lifetime spent understanding ships and the sea, found himself facing an impossible equation. The United States Navy's own projections indicated that America would need to transport millions of troops across both the Atlantic and Pacific, along with the staggering quantities of equipment, ammunition, fuel, and supplies required to sustain global warfare on an unprecedented scale. The existing merchant marine, even combined with whatever vessels Britain could spare, represented perhaps 1/10 of the required capacity. Traditional shipbuilding methods, refined over centuries of maritime craftsmanship, typically required 18 months to 2 years to complete a single cargo vessel. The careful selection of materials, the precise fitting of each component, the methodical construction that ensured decades of reliable service. These time-honored approaches had served peacetime commerce well, but they were utterly inadequate for the tempo of modern warfare. Yet even as the crisis deepened, an intriguing possibility began to emerge from an unexpected quarter. Henry Kaiser, a man whose background lay not in shipbuilding, but in massive construction projects, dams, highways, bridges, had been observing the maritime crisis with the calculating eye of an engineer who specialized in achieving the impossible. Kaiser had built the Hoover Dam ahead of schedule and under budget by revolutionizing construction techniques, applying principles of mass production and systematic efficiency that had never before been attempted on such a scale. Now, as he studied the sleek lines of traditional cargo vessels, Kaiser saw something that the maritime establishment had missed entirely. These ships, for all their elegant engineering, were being built using methods that Henry Ford had already proven obsolete in automobile manufacturing. Each vessel was essentially a custom creation, assembled by skilled craftsmen who shaped and fitted components through experience and intuition rather than standardized processes. The concept that began forming in Kaiser's mind was both audacious and heretical. What if cargo ships could be built like automobiles, or like the massive concrete structures he had mastered? What if the centuries-old tradition of ship construction could be broken down into standardized, repeatable processes that could be taught to workers who had never seen the ocean? The maritime experts were skeptical, to put it mildly. Shipbuilding, they argued, was an art as much as a science. The stresses imposed by ocean swells, the complex interplay of hull design and cargo distribution, the thousand subtle factors that determined whether a vessel would survive North Atlantic storms, these could not be reduced to assembly line procedures. Ships were not automobiles. The sea was an unforgiving environment that demanded the highest standards of craftsmanship and the most careful attention to detail. But Kaiser had encountered such skepticism before, when he proposed building the Hoover Dam using revolutionary techniques that violated established engineering wisdom. He had learned that the key to achieving the impossible lay not in abandoning expertise, but in systematizing it, breaking down complex processes into components that could be standardized, measured, considered, and continuously improved. The challenge was staggering in its scope. A typical cargo vessel contained approximately 10,000 tons of steel, shaped into hundreds of thousands of individual components. The hull alone required thousands of precisely curved plates, each one carefully fitted to create the smooth lines that would slice efficiently through ocean swells. The internal structure demanded miles of welding, creating a framework strong enough to flex with the sea's motion without breaking apart. Traditional shipyards approached this complexity through the accumulated wisdom of master craftsmen, men who could look at a blueprint and instinctively understand how each component would behave under stress. They worked with teams of skilled welders, fitters, and riggers who had learned their trades through years of apprenticeship. The entire process was organic, flexible, and utterly dependent on human expertise that could not be quickly replicated. Kaiser envisioned something entirely different: production lines where workers with minimal training could perform specific, standardized tasks, where components could be prefabricated in controlled environments and then assembled with mechanical precision, where the entire construction process could be measured, timed, and systematically improved. It was a vision that promised to transform months of careful craftsmanship into weeks of intensive production. The obstacles seemed insurmountable. America's existing shipbuilding capacity was already strained to its limits, with every experienced worker desperately needed for naval construction. The specialized steel required for ship hulls was in critically short supply, with competing demands from aircraft manufacturers, tank producers, and artillery foundries. Even if the production challenges could be solved, where would the workers come from? The precision welding required for ship construction typically took years to master, and there simply wasn't time to train a new generation of maritime craftsmen. Yet as 1941 progressed and the shipping crisis deepened, these seemingly impossible challenges began to look less daunting than the alternative. Intelligence reports painted an increasingly grim picture of German submarine capabilities. New U-boat designs were entering service with longer range and greater torpedo capacity. The German Navy was developing coordinated attack techniques that could overwhelm even well-protected convoys. Most ominously, intercepted communications suggested that the Germans were planning a massive expansion of their submarine fleet, with production targets that would triple their Atlantic presence within 18 months. The mathematics remained relentless. Unless the Allies could dramatically increase their cargo capacity, the war would be lost not through military defeat, but through simple starvation. Britain's food reserves were measured in weeks, not months. The raw materials required for aircraft production, tank manufacturing, and ammunition production all depended on those vulnerable sea lanes. Even if American industry could achieve unprecedented levels of production, none of it would matter if the goods could not be safely transported to where they were needed. In this context of mounting desperation, Kaiser's radical vision began to attract serious attention from the highest levels of government. The traditional approaches to shipbuilding, however refined and proven, simply could not scale to meet the demands of global warfare. Something unprecedented was required: a complete reimagining of how ships could be built and how quickly they could be launched into those dangerous waters. The stage was set for one of the most remarkable industrial achievements in human history: a transformation that would challenge every assumption about manufacturing, quality, and the very nature of skilled labor. The Liberty ships were about to be born, and with them a new understanding of what American industry could accomplish when survival itself hung in the balance. But first, the skeptics would need to be convinced. The impossible would need to be made routine, and an entire workforce would need to be created from nothing. All while the grey waters of the Atlantic continued to claim their daily toll of ships, cargo, and the irreplaceable men who sailed them into harm's way. The birth of an idea, the genesis of what would become the Liberty ship, can be traced to a cramped office in London, where British naval architects were wrestling with a problem that seemed to have no elegant solution. They needed ships, many ships. and they needed them faster than any shipyard had ever produced them before. The traditional approach of custom designing each vessel with its months of detailed blueprints and specialized components was a luxury the war could not afford. So they turned instead to an existing design, a simple, sturdy cargo vessel that had already proven itself in peacetime service. The British chose to adapt a design from a ship called the Ocean class, vessels that were neither beautiful nor particularly fast, but possessed something far more valuable in wartime. They were uncomplicated. Every line of their hull spoke to functionality over form. Wide cargo holds that could swallow tanks, trucks, and the countless tons of supplies that modern warfare devoured. Their design eliminated the decorative flourishes and complex curves that made ships beautiful but difficult to build. These vessels would be 441 feet long and 57 feet wide, dimensions that represented careful calculation rather than aesthetic preference. Their single-screw propulsion system could push them through the water at a modest 11 knots. Not fast enough to outrun a submarine, but fast enough to maintain convoy formation across the vast distances of the Atlantic. Most importantly, every component had been chosen for its availability and ease of manufacture. Standard steel plates, simple riveted construction, and proven steam engines that any competent machinist could understand and repair. But it was Henry J. Kaiser who saw beyond the basic design to its revolutionary potential. Kaiser was not a shipbuilder by training. He was a construction magnate who had built dams and highways, a man who understood the power of systematic thinking applied to seemingly impossible challenges. When he examined the British specifications, he saw not just a ship, but an opportunity to completely reimagine how ships could be built. The key insight that would transform everything was deceptively simple: welding instead of riveting. Traditional shipbuilding had relied on rivets, thousands upon thousands of hot metal bolts driven through overlapping steel plates by teams of skilled workers. Each rivet required precise placement, careful heating, and expert installation. A single large ship might require over 1 million rivets, each one representing minutes of skilled labor and potential points of failure. Kaiser proposed to weld the ships together instead, joining the steel plates with continuous seams of melted metal that would be stronger than rivets and require far fewer skilled workers to install. The welding process could be learned in weeks rather than the years required to train a master riveter. More importantly, welding could be done by women, by older workers, by anyone with steady hands and the determination to learn a new skill. The maritime establishment reacted to this proposal with the kind of skepticism reserved for ideas that challenge fundamental assumptions. Welding was acceptable for repair work, they argued, but building an entire ship through welded construction was unprecedented, and therefore dangerous. Salt water and welded seams had not been tested together over the years and storms that every merchant vessel would face. What if the welds failed in heavy seas? What if metal fatigue caused catastrophic hull failure? Kaiser's response was characteristically direct. They would test the welds until they were certain of their strength, and they would build ships so quickly that even if some failed, the overall production rate would more than compensate for any losses. It was a calculation that spoke to the desperate mathematics of wartime, where perfect solutions took too long, and good enough solutions, implemented quickly, could save more lives than perfect solutions that arrived too late. The resistance Kaiser faced was not merely technical, it was cultural and economic. Established shipyards had invested decades in developing their riveting expertise. Their workforces were organized around traditional methods, their tools designed for conventional construction, their reputations built on craftsmanship that Kaiser's approach seemed to dismiss. When he proposed to build ships in a matter of weeks rather than months, industry veterans saw not innovation, but recklessness. Yet Kaiser possessed something his critics lacked: a clear understanding of what the war demanded versus what peacetime shipbuilding had traditionally provided. He had built the Hoover Dam by breaking down an enormous project into manageable components, then organizing those components into an efficient sequence of construction. The same principles, he argued, could be applied to shipbuilding, if one were willing to abandon the assumption that ships had to be built the way they had always been built. The breakthrough came when Kaiser partnered with Albert Kahn, an industrial architect who had revolutionized factory design for the automobile industry. Kahn understood that the building itself could be a tool for increasing productivity. that the arrangement of workstations, the flow of materials, and the organization of space could dramatically impact how quickly complex products could be assembled. Together, Kaiser and Kahn designed shipyards that functioned more like enormous assembly lines than traditional maritime construction facilities. Instead of building ships from keel to superstructure in a single location, they would prefabricate major sections in specialized workshops, then move these sections to the shipway for final assembly. Hull sections could be welded together in controlled environments, tested for quality, then transported to where they were needed. This approach required a complete reimagining of the shipyard itself. Traditional yards were collections of individual building ways where ships grew slowly from their foundations upward. Kaiser's yards would be integrated manufacturing facilities where different teams worked simultaneously on different aspects of the same ship. While one crew laid the keel, another would be welding together the hull sections that would be needed weeks later. While welders assembled the main structure, other teams would be preparing the engines, the electrical systems, and the thousands of components that would transform steel plates into functioning vessels. The logistical complexity was staggering. Every Liberty ship required approximately 2,700 tons of steel, delivered in precisely the right shapes and sizes to the right workstations at the right times. Delays in any single component could halt production across multiple ships. The coordination required was more akin to conducting a symphony orchestra than to traditional shipbuilding, where individual craftsmen worked at their own pace toward completion. Kaiser's vision extended beyond the ships themselves to the workforce that would build them. He recognized that the war had created an unprecedented labor shortage in skilled trades, but had also created an unprecedented pool of motivated workers willing to learn new skills. Women whose husbands had gone to war, older men who had been considered past their productive years, young people who had never imagined working in heavy industry, all could be trained to perform specific tasks in the shipbuilding process. The training programs Kaiser developed were themselves revolutionary. Instead of the traditional apprenticeship system that took years to produce a journeyman, his programs focused on teaching workers to perform specific operations with high competency. A welder didn't need to understand every aspect of metallurgy. They needed to produce consistent, strong welds on the particular joints they would encounter in Liberty ship construction. This focused approach allowed training times to be measured in weeks rather than years. When the British Purchasing Commission finally placed their initial order for 60 Liberty ships, it represented more than a contract. It was a validation of an entirely new approach to industrial production under wartime pressure. The order specified delivery schedules that seemed impossible by conventional standards, ships completed in months rather than the year or more that traditional construction required. But Kaiser had not been idle while waiting for official approval. He had already begun constructing the shipyards that would build these vessels, organizing the supply chains that would feed them materials, and recruiting the workforce that would transform his vision into reality. The Richmond shipyard in California was rising from what had been empty land just months before. Vast assembly halls, enormous cranes, and the infrastructure needed to support round-the-clock production. The skeptics who had dismissed Kaiser's approach as industrial fantasy were about to witness something unprecedented in maritime history. The Liberty ship program was no longer just an idea or a proposal. It was becoming a reality that would challenge every assumption about what American industry could accomplish when survival itself provided the motivation. As 1941 drew toward its close, the first Liberty ship keels were being laid in yards that had not existed a year earlier, by workers who were learning skills they had never imagined needing, using techniques that maritime tradition had never embraced. The Atlantic still claimed its daily toll of Allied shipping, but for the first time since the war began, production was beginning to match destruction, and the promise existed that it might soon exceed it. Assembly lines of steel. The transformation began not in the shipyards themselves, but in the sprawling industrial complexes that Kaiser and his partners constructed across the American landscape. From Pittsburgh's steel mills to Detroit's automotive plants, from the wheat fields of Kansas to the lumber forests of Oregon, an entirely new kind of manufacturing ecosystem was taking shape, one designed not to build cars or tractors, but to fabricate the components of maritime vessels on an unprecedented scale. The breakthrough lay in Kaiser's fundamental reimagining of how a ship could be conceived. Where traditional shipbuilding saw a vessel as a single, continuous structure to be assembled piece by piece in a waterfront yard, Kaiser envisioned something closer to an enormous three-dimensional puzzle, one whose major pieces could be manufactured hundreds of miles inland, then transported to the coast for final assembly. In the converted automobile factories of Michigan, workers who had spent years installing engines in Buicks and Chevrolets now found themselves welding together massive steel sections that would become the forward holds of Liberty ships. The assembly line techniques that Henry Ford had perfected for mass-producing cars were adapted with remarkable ingenuity for maritime construction. Where once a single ship section might have required weeks of custom fabrication, these industrial lines could complete identical components in a matter of days. The scale of coordination required was staggering. A single Liberty ship consisted of approximately 250 major prefabricated sections, each weighing between 5 and 30 tons. These ranged from complete engine room assemblies to fully outfitted crew quarters, from massive cargo hold segments to intricate bridge superstructures. Every piece had to be manufactured to precise specifications that allowed no room for the traditional maritime practice of custom-fitting components during construction. In the sprawling factory complexes of Pennsylvania and Ohio, the rhythm of production became almost hypnotic. Overhead cranes moved in carefully choreographed patterns, lifting massive steel plates into position while teams of welders worked in synchronized shifts around the clock. The sound was distinctive, not the irregular hammering of traditional shipyards, but the steady mechanical pulse of industrial mass production applied to maritime construction. The workers themselves represented one of the most remarkable aspects of this transformation. As experienced shipbuilders were in desperately short supply, Kaiser's yards drew their workforce from an entirely different pool of American labor. Former farmers learned to operate massive cutting torches. Housewives mastered the precise art of welding aluminum superstructures. Retired mechanics found themselves assembling complex marine electrical systems they had never seen before. The influx of women into these roles was particularly striking. In the Richmond yards alone, nearly 30% of the workforce was female by early 1942. Women who had taken on responsibilities that maritime tradition had never contemplated. They operated cranes that could lift 20-ton sections, managed quality control for critical structural welds, and coordinated the complex logistics of moving massive components from factory floor to railcar to final assembly. Training these inexperienced workers required innovations almost as revolutionary as the production techniques themselves. Kaiser's industrial engineers developed what they called process standardization, breaking down complex shipbuilding tasks into smaller learnable components that could be mastered in weeks rather than the years traditionally required for maritime craftsmanship. Color-coded welding systems allowed new workers to identify exactly which type of joint they were creating. Jigs and templates ensured that even inexperienced hands could position components with the precision required for mass production. Most importantly, detailed instruction manuals, written in clear, non-technical language, guided workers through procedures that had previously existed only in the minds of master craftsmen. The logistics of moving these massive components from inland factories to coastal assembly points created its own set of extraordinary challenges. Railroad cars had to be specially modified to carry 30-ton ship sections across thousands of miles of track. Highway routes were carefully planned to accommodate the movement of components too large for standard rail transport. In some cases, entire bridge structures had to be temporarily modified to allow the passage of oversized maritime assemblies. The coordination required was military in its precision. A single day's delay in delivering engine room components from Detroit could idle hundreds of workers at the Richmond assembly yards. Components manufactured in Pennsylvania had to arrive at West Coast facilities in exactly the right sequence. Arriving too early meant costly storage problems, while arriving too late could disrupt the entire assembly schedule. To manage this complexity, Kaiser's organization developed some of the most sophisticated logistics systems that American industry had yet seen. Detailed tracking systems monitored every major component from the moment manufacturing began until it was welded into place in the final vessel. Communication networks linked factories across the continent, allowing real-time coordination of production schedules and shipping priorities. The factories themselves operated on schedules that defied traditional industrial practice. 3 full shifts worked around the clock, 7 days a week. Under the harsh glare of industrial lighting, the work never stopped. Welders and crane operators and quality inspectors maintaining the relentless pace that the Battle of the Atlantic demanded. In the great stamping plants where steel plates were cut and shaped, massive hydraulic presses worked with mechanical precision, turning raw steel into the curved hull sections that would soon carry cargo across submarine-infested waters. The noise was tremendous. The thunderous impact of multi-ton presses shaping steel plates, the screaming whine of cutting torches, the steady rumble of overhead conveyors moving components through the production process. Quality control in this mass production environment required entirely new approaches. Traditional shipbuilding had relied on the experienced eye of master craftsmen to ensure structural integrity. Kaiser's system instead developed standardized testing procedures that could be applied by relatively inexperienced workers. Welding quality was verified through systematic X-ray inspection. Steel plate thickness was confirmed through precise measurement protocols. Critical joints were stress-tested according to detailed specifications that left nothing to individual judgment. The modular construction concept proved its worth most dramatically in the time savings it generated. Where traditional shipbuilding required that each vessel be assembled sequentially, one section completed before the next could begin, Kaiser's approach allowed multiple teams to work simultaneously on different components of the same ship. While the keel and forward sections were being assembled in the main yard, the engine room could be completed in a separate facility, the superstructure fabricated in a third location, and the cargo handling equipment prepared in a fourth. This parallel construction approach compressed what had traditionally been a sequential process into a series of simultaneous operations. The final assembly became less like traditional shipbuilding and more like the final stage of an enormous manufacturing process, bringing together components that had been precisely engineered to fit together with minimal custom adjustment. The standardization that made this possible extended to every bolt, every pipe fitting, every electrical connection. Components manufactured in Michigan had to interface perfectly with sections built in Pennsylvania. Electrical systems fabricated in Ohio had to connect seamlessly with engine room assemblies completed in California. This required a level of precision and standardization that the maritime industry had never before attempted. By the spring of 1942, the rhythm of this industrial transformation had become a steady pulse across the American manufacturing landscape. In dozens of cities, in hundreds of factories, the components of Allied victory were taking shape through the application of mass production techniques to the ancient craft of shipbuilding. The workers, many of whom had never seen the ocean, labored with the knowledge that their precision and dedication would determine whether vital supplies reached embattled Britain. The assembly lines of steel had become more than an industrial process. They represented a fundamental transformation in how America understood the relationship between manufacturing capability and military necessity. Traditional craftsmanship had given way to systematic production. Individual expertise had been supplemented by standardized procedures, and the ancient rhythm of maritime construction had been replaced by the relentless pulse of modern industrial capacity, applied to the desperate requirements of global war. As these massive components moved along their carefully coordinated paths from factory to rail yard to assembly point, they carried with them the promise that American industrial might could match the challenge of German submarine warfare. The question that remained was whether this promise could be fulfilled quickly enough to prevent the strangulation of Allied supply lines, and whether the quality of mass-produced vessels could match the reliability that the harsh Atlantic demanded. Hannah raising the framework. The first light of dawn would reveal scenes that would have seemed impossible just months before. Across the sprawling shipyards of Richmond, California, and Portland, Oregon, massive steel frameworks rose from concrete slipways like the skeletons of sleeping giants. The prefabricated sections that had traveled thousands of miles from inland factories now waited in carefully organized staging areas, each piece numbered and tagged according to the master blueprints that had transformed shipbuilding from an art into a science. The assembly process began with the keel, that fundamental backbone upon which everything else would depend. Teams of workers guided the massive steel girders into position using overhead cranes that could lift 40 tons with precision, that would have impressed the finest watchmaker. The welders moved in first, their torches creating brilliant arcs of light that danced across the growing framework. Unlike the traditional riveting that had dominated shipbuilding for generations, these welded joints created seamless bonds of steel that were both faster to complete and stronger under stress. Section by section, the Liberty ships took shape. The hull plates, manufactured to exact specifications in distant factories, fitted together with remarkable precision. Each plate had been cut and shaped by machines that could reproduce identical components with tolerances measured in fractions of inches. The workers who positioned these massive steel sections had learned to read the complex assembly diagrams that showed exactly where each piece belonged in the greater whole. The scale of these vessels demanded constant recalibration of perspective. A single Liberty ship stretched 441 feet from bow to stern, longer than a city block and nearly as wide as a football field. The cargo holds could swallow entire freight trains, while the engine compartment housed machinery powerful enough to drive this floating warehouse at 11 knots across thousands of miles of open ocean. Standing beside these growing hulls, workers often paused to marvel at the sheer magnitude of what they were creating. The welding crews worked in carefully coordinated teams, each member responsible for specific joints and connections. The lead welders, many of whom had learned their trade in just weeks rather than the traditional years of apprenticeship, guided their torches along seams that would need to withstand the crushing pressure of North Atlantic storms. Behind them came the inspection teams, checking each weld for the quality and integrity that would mean the difference between safe passage and catastrophic failure in hostile waters. Overhead, the massive gantry cranes moved in a carefully choreographed dance. These industrial giants could lift entire prefabricated sections of superstructure and lower them into position with movements that seemed almost gentle despite the enormous forces involved. The crane operators, perched in cabs high above the shipyard floor, developed an almost intuitive sense for the weight and balance of their loads. They could position a 20-ton section of deck plating within inches of its final location, allowing the assembly crews to make fine adjustments before the welders sealed it permanently in place. The shipyards operated around the clock, with 3 full shifts maintaining continuous progress on dozens of vessels simultaneously. As the day shift handed over their tools and responsibilities to the evening crews, the yards remained ablaze with the light of welding torches and the warm glow of work lamps. The night shift brought its own rhythm to the construction process, a slightly more deliberate pace that allowed for careful attention to the complex details that daylight work sometimes rushed past. The dangers were constant and real. Molten metal from welding operations could cause severe burns, while the massive steel sections being moved overhead demanded constant awareness and quick reflexes. The shipyards developed elaborate safety protocols, but the pressure to maintain production schedules sometimes pushed both workers and equipment to their limits. Medical stations operated continuously, treating everything from minor cuts to more serious injuries that resulted from the inherently hazardous nature of heavy construction work. Yet the sense of purpose that permeated these industrial cathedrals transformed even the most difficult working conditions into something approaching a crusade. Workers understood that every ship they completed represented thousands of tons of supplies that could reach embattled allies, ammunition for Soviet forces defending Stalingrad, food for British civilians enduring rationing, fuel for aircraft that would eventually carry the war back to German territory. This knowledge sustained them through 16-hour shifts and working conditions that would have been unthinkable in peacetime. The innovation extended beyond the basic construction techniques. Shipyards experimented with new methods for moving and positioning the massive components. Some yards developed specialized rail systems that could transport entire hull sections from assembly areas to the slipways. Others created floating dry docks that allowed ships to be launched before completion, freeing up the slipways for new construction while finishing work continued at nearby piers. The coordination required to orchestrate these complex operations challenged every aspect of traditional shipyard management. Supervisors used elaborate scheduling boards that tracked the progress of dozens of ships through various stages of construction. Supply coordinators ensured that the right materials arrived at the right locations precisely when the assembly crews needed them. Any delay in one area could cascade through the entire production system, potentially affecting the completion schedules of multiple vessels. The workers themselves became part of an elaborate human machine, with specialized teams responsible for specific aspects of the construction process. The hull crews focused on the basic structural framework, while the machinery installation teams prepared the engine rooms and propulsion systems. Electrical specialists ran the complex wiring that would power everything from navigation equipment to cargo handling gear. Each group had developed its own techniques and shortcuts that increased efficiency while maintaining the quality standards that ocean service demanded. As winter gave way to spring in 1942, the shipyards began achieving production rates that astounded even Henry Kaiser's optimistic projections. The Richmond Shipyard No. 2 became the stage for an achievement that would demonstrate the full potential of American industrial mobilization. The keel for a Liberty ship designated as the Robert E. Peary was laid down on November 8, 1942, as part of a special effort to showcase the peak efficiency that the program had achieved. The construction of the Robert E. Peary became a carefully orchestrated demonstration of everything the Liberty ship program had learned about mass production shipbuilding. Every prefabricated component had been prepared in advance and staged for immediate installation. The welding crews had rehearsed their sequences until they could work with the precision of a ballet company. The crane operators had planned every lift and movement to minimize the time between operations. For 4 days and 15 hours, the Richmond shipyard operated with an intensity that pushed both workers and equipment to their absolute limits. The assembly proceeded with mechanical precision as hull sections were positioned and welded. Machinery was installed and tested, and the superstructure took shape with remarkable speed. Workers from other shifts volunteered their off-duty time to witness and support this demonstration of American industrial capability. The sense of pride that filled the shipyard as the Robert E. Peary neared completion reflected something deeper than mere satisfaction with efficient production. These workers had proven that American industry could not only match the German submarine threat, but could exceed it by margins that would ultimately prove decisive. Every rivet, every weld, every precisely fitted component represented a small victory in the larger struggle for industrial supremacy that would determine the war's outcome. The launching of the Robert E. Peary, 4 days and 15 hours after her keel was laid, sent ripples of amazement and pride throughout the Allied world. This single vessel, built faster than many traditional shipyards could complete major repairs, demonstrated that American shipbuilding had achieved a level of efficiency that transformed the strategic balance of the Atlantic War. The workers who had made this achievement possible understood that they had participated in something that would be remembered long after the last Liberty ship had completed her final voyage. As the Robert E. Peary slid down the ways into San Francisco Bay, her hull gleaming with fresh paint and her equipment ready for immediate service, she carried with her the hopes and determination of everyone who had contributed to her construction. The cheers that erupted from the assembled workers echoed across the water, a sound of triumph that spoke to the power of American industry when focused on a common purpose. From the yard to the sea, the cheers that had erupted across San Francisco Bay seemed to linger in the salt air, but they represented only the beginning of each Liberty ship's true purpose. As the Robert E. Peary settled into her berth for final fitting out, similar scenes of triumph were unfolding at shipyards from Maine to California. Each launch a celebration not just of industrial achievement, but of collective determination in the face of an existential threat. The launch ceremonies themselves had evolved into deeply meaningful rituals that brought together entire communities. At the Bethlehem Fairfield shipyard in Baltimore, thousands would gather on makeshift bleachers constructed along the waterfront, their faces turned toward the massive hull that dominated the slipway. Workers who had shaped every plate and welded every seam stood shoulder to shoulder with their families, many seeing for the first time the complete vessel their loved ones had labored to create. Government officials and military representatives occupied places of honor on the launching platform. But the real stars were the ordinary Americans whose skilled hands had made this moment possible. The traditional bottle of champagne, swung against the bow by a carefully chosen sponsor, often the wife of a naval officer or the mother of a serviceman overseas, would shatter in a spray of foam and glass, releasing the massive ship from her restraints. The sound of the breaking bottle was immediately followed by the deep groaning of timber and steel as thousands of tons of vessel began their stately slide toward the water. Launchways greased with tons of tallow and soap created a slick pathway that allowed even the heaviest ships to gather momentum with surprising grace. As each Liberty ship entered the water with a tremendous splash that sent waves rolling across the harbor, the crowd's cheers would mix with the sharp blast of ship horns and factory whistles. These were moments of pure joy. Brief interludes when the grinding pressures of wartime production gave way to celebration and hope. Workers who had spent months focused on individual tasks could finally see their collective achievement in its full glory. A complete ocean-going vessel ready to carry the tools of victory across dangerous seas. But the real test of each Liberty ship began after the champagne had dried and the crowds had dispersed. In the final fitting-out berths, teams of specialists would spend days installing the complex systems that would keep these vessels operational in the harsh environment of the North Atlantic. The engine rooms, located amidships for optimal weight distribution, housed the massive triple-expansion steam engines that would drive each ship at her steady 11 knots across thousands of miles of ocean. These engines, while not particularly fast by modern standards, were chosen for their reliability and ease of maintenance. Critical factors when ships might spend weeks at sea without access to major repair facilities. The cargo holds, designed with mathematical precision to maximize carrying capacity while maintaining structural integrity, could accommodate everything from tanks and aircraft to the tons of food, ammunition, and medical supplies that kept Allied forces operational. Each hold was equipped with heavy-duty winches and cargo booms capable of handling loads weighing several tons, while reinforced deck plating could support the weight of the heaviest military equipment. The utilitarian design philosophy that governed every aspect of Liberty ship construction was nowhere more evident than in these vast, echoing spaces where function took absolute precedence over form. Living quarters for the merchant crews reflected the same practical approach. Officers' cabins, while modest by peacetime standards, provided the basic amenities needed for long voyages. A bunk, a small desk, storage for personal belongings, and access to the ship's communication systems. Crew quarters in the forward section housed the ordinary seamen, oilers, and cooks, whose skills would keep each vessel operating efficiently during voyages that might last several weeks. These men, many of them experienced merchant mariners, but others newly trained for wartime service, understood that their comfortable return home depended entirely on their ship's ability to deliver her cargo and survive the journey. The dangers they would face were never far from anyone's mind during these launch celebrations. German U-boat commanders had turned the Atlantic shipping lanes into hunting grounds where a single torpedo could send a fully loaded Liberty ship to the bottom in minutes. The crews who would sail these vessels knew the statistics. Hundreds of merchant ships had already been lost, along with thousands of their crew members. Yet they also knew that without their courage and skill, the war effort would collapse under the weight of its own logistical requirements. As 1943 progressed into 1944, the sight of Liberty ship convoys departing American ports became a regular and inspiring spectacle. From the harbors of New York, Boston, Norfolk, and dozens of smaller ports, these utilitarian vessels would form up in precise formations under the protection of naval escorts. The convoys themselves represented another triumph of coordination and planning. Dozens of ships sailing in carefully maintained positions, their courses plotted to avoid known submarine concentrations while making the most efficient use of favorable weather patterns. Watching a convoy departure from the shore, observers could see the physical manifestation of American industrial power applied to the challenge of global warfare. Each ship represented thousands of hours of labor, tons of steel and other materials, and the coordinated efforts of workers in dozens of different industries. Multiplied across an entire convoy, the economic and human investment was staggering. Yet it was being repeated week after week as the production lines continued their relentless output. The impact on the communities that built these ships extended far beyond the paychecks that workers took home each week. Entire families found their lives transformed by the demands and opportunities of wartime shipbuilding. Women who had never worked outside their homes discovered they possessed talents for precision welding and complex assembly work. Older men whose skills had seemed obsolete in the modern economy found themselves training younger workers in techniques that proved essential for rapid construction. Even children contributed to the effort. participating in scrap metal drives and victory gardens that supported the massive resource requirements of continuous production. The shipyard communities developed their own cultures and traditions, centered around the shared purpose of defeating fascism through industrial might. Company newsletters celebrated production records and recognized outstanding individual contributions. Social clubs organized around work shifts created networks of friendship and mutual support that helped workers cope with the physical and emotional demands of their jobs. Victory gardens planted on unused shipyard property provided fresh vegetables while reinforcing the connection between individual effort and collective success. As each new Liberty ship completed her trials and prepared for her first voyage, she carried with her not just cargo and crew, but the hopes and determination of everyone who had contributed to her creation. The welders who had joined her hull plates, the crane operators who had positioned her superstructure, the painters who had applied her final coat of grey paint. All of them had invested something of themselves in her success. Her safe arrival at a British or Soviet port would validate their efforts and justify the sacrifices they had made to maintain the production schedules that kept the assembly lines moving. These ships, built by ordinary Americans working with extraordinary dedication, were becoming the steel lifeline that would ultimately strangle the Axis powers and secure Allied victory. Echoes of victory. The victory they helped secure would outlast the ships themselves by decades. As 1945 drew to a close and the last Liberty ship slid down the ways, these vessels faced a peacetime world that had little need for their utilitarian design and modest speed. The wartime emergency that had justified their rapid construction was over. But their story was far from finished. In the months following Japan's surrender, the question of what to do with nearly 3,000 Liberty ships became a logistical challenge almost as complex as their original construction. The Maritime Commission found itself managing the world's largest merchant fleet, built for war, but now seeking purpose in peace. Some ships continued carrying cargo on commercial routes, sold to shipping companies eager to capitalize on the post-war economic boom. Others were laid up in vast anchorages, their hulls stretching to the horizon like steel forests reflecting the changing light of dawn and dusk. The fate of individual ships often reflected the pragmatic spirit that had created them. Many were converted for new purposes that their designers never imagined. Passenger vessels carrying war brides across the Atlantic, grain ships feeding a hungry world, even floating warehouses anchored in remote harbors. Some found their way to foreign flags, carrying the techniques of American mass production to shipyards around the globe. Others were broken up for scrap, their steel recycled into the infrastructure of a peacetime economy that was itself being rebuilt on industrial principles pioneered in those wartime shipyards. But the true legacy of the Liberty ships lived not in their steel hulls, but in the people who had built them. In the years that followed the war, those workers carried with them something more valuable than technical knowledge. They had learned what was possible when ordinary people committed themselves to an extraordinary purpose. The woman who had mastered welding techniques in a Richmond shipyard brought that same precision to her post-war career. The man who had coordinated the movement of massive hull sections understood logistics in ways that would serve him well in civilian industry. The social transformations that had begun in those shipyards continued to ripple through American society long after the last Liberty ship was launched. Women who had proven themselves capable of complex industrial work were not easily convinced to abandon those skills. African American workers who had found opportunities in the integrated shipyards carried those experiences into the civil rights struggles of the following decades. The barriers that had been broken down in the name of wartime necessity had created precedents that could not be easily forgotten. The shipbuilding techniques themselves evolved and spread throughout American industry. The modular construction methods that had enabled rapid Liberty ship assembly found new applications in housing construction, where prefabricated components could address the post-war housing shortage with the same efficiency they had once brought to maritime production. The quality control systems that had ensured consistent welds in ship hulls were adapted for automobile manufacturing and aerospace engineering. Perhaps most importantly, the Liberty ship program had demonstrated the power of systematic thinking applied to seemingly impossible challenges. The lesson was not simply that America could build ships quickly when necessary. It was that careful analysis, standardized procedures, and coordinated effort could overcome obstacles that had previously seemed insurmountable. This understanding would prove invaluable in the decades that followed, from the Marshall Plan's reconstruction of Europe to the space program's methodical approach to reaching the moon. In the quiet moments of evening, when former shipyard workers reflected on their wartime service, many spoke not of the ships themselves, but of the communities they had built alongside the steel hulls. The friendships forged in those intense months of shared purpose, the satisfaction of mastering new skills under pressure, the knowledge that their individual efforts had contributed to something larger than themselves. These memories carried a warmth that no amount of post-war prosperity could diminish. The Liberty ships had been designed as temporary solutions to an urgent problem, but they had created something permanent in the people who built them. They had proven that American industrial capacity was limited not by resources or technology, but only by imagination and will. They had shown that ordinary citizens, given proper training and clear purpose, could accomplish feats that experts had declared impossible. As the last of these vessels disappeared from active service in the following decades, their influence remained embedded in American industry and culture. The shipyards themselves were often converted to other uses, but the lessons learned in their construction lived on. In the engineers who had cut their teeth on Liberty ship design, in the managers who had learned to coordinate complex production schedules, in the workers who had discovered capabilities they never knew they possessed. The echoes of that great wartime effort would resonate through the American economy for generations. A reminder that the most sophisticated technology means nothing without the human dedication to use it wisely, and that the greatest victories are often won not by heroes but by ordinary people doing extraordinary work. Hakan, a quiet legacy. Tonight, as you rest, you carry forward something of that same spirit that filled those shipyards. The quiet knowledge that when humanity faces its greatest challenges, ordinary people find extraordinary ways to rise and meet them. The Liberty ships themselves may have long since sailed into history. Most of them scrapped or converted, their steel repurposed into bridges and buildings and the infrastructure of peacetime. But their true cargo was never the tanks or grain or medical supplies they carried across dangerous waters. What they truly transported was proof that a free people working together with shared purpose could outbuild tyranny, could outproduce oppression, could weld together a victory that seemed impossible when the first keel was laid. In every rivet driven by hands that had never before touched a ship, in every crane operator who learned to dance those massive sections into place, in every welder whose torch became an instrument of liberation, there was a quiet heroism that asked for no medals, no monuments, only the chance to do meaningful work. The women who left their homes to build these vessels returned to reshape their communities. The techniques perfected in those emergency yards became the foundation for decades of American industrial leadership, and the lesson that complex problems yield to systematic thinking and collective effort became part of our national character. Henry Kaiser's great insight was not just about welding or assembly lines. It was about trusting people to learn, to adapt, to exceed what they believed possible about themselves. These ships were never beautiful in the classical sense. They were built for function, for speed, for the urgent business of winning a war. But there was something beautiful in their very plainness, their honest declaration that substance matters more than style when civilization itself hangs in the balance. They were democracy made manifest in steel, proof that free people, given the tools and the trust, will always find a way. And so tonight, as you drift towards sleep, let yourself rest in the knowledge that this same capacity for collective achievement lives on, that the same ingenuity that turned inland factories into shipyards still flows through human hearts and minds, and that somewhere, in ways both seen and unseen, ordinary people are still doing the extraordinary work of building tomorrow. One careful weld, one thoughtful decision, one act of quiet dedication at a time.